Oh, so fast. On MacBook.
Because of PWA problem.
Absolutely. So thanks for coming and thus far listening to me, I hope. So my presentation is going to be on a progressive web app, as Jasper already explained, not just in a normal situation like this, but in an actual elevator shaft or lift shaft. Can I see hands who prefer lift and who prefer elevator? Elevator?
Elevator, yeah, sure.
Okay, cool. Let's do elevator, which is American. By the way, if you didn't know. So I'm going to talk to you about this progressive web app that me together with a couple of people, one of them is Nena, built for one of our clients. The thing that this app does is it helps elevator inspectors do like quality inspections. But I'll get to that in a bit, because first I want to do a short recap. Obviously, Jasper already told a bit about progressive web apps and what they are. This is the concept as Google defines it. Progressive web apps are user experience that have the reach of the web. All right, so this, I don't know, I guess. And then there are three sort of bylines below that. And they say a progressive web app should be reliable, which is about network independency and about how you use the network. It should be fast, as in not just as in performant or in perceived performance, but also as in how you use it, and that it's responsive and that it works smoothly and nicely. And it should be engaging, so that means it should be like a natural or native app it should have a natural app behavior. You have this, install on home screen stuff, for instance. So when you think about it, this is only partially about technology, right? So a progressive web app, we always talk about just the service worker because probably it's code and we like to develop stuff. But a very large part of progressive web apps is actually about interaction design, about micro animations, and about architecture as well. So I'm going to talk about all of these things and not just the service worker. But there is a lot of service worker in my presentation, luckily. So what is the assignment that we got, or let's say the call that we got from our client? Let's talk about that first. It's about lift inspections. And so this company does lift inspections not just for these kinds of, or I'm saying lift, right? It should be elevator. I wish I could, if this was a website. Replace all. Elevator. An elevator inspection, and not just these kinds of elevators, but also the ones that you have outside on a building for cleaning windows and escalators, for instance. And they provide a service to installations or building managers to do these reports and make a financial overview of their installations. And with these reports, they can, ask for replacements of parts and everything. And they do this every half year, every year or so. And to make these, to do these inspections, we have lift inspectors. This is August over here. He is a lift inspector, and he is also the guy whose life we're trying to improve, right? So he's working with his Samsung tablet. It was one of the, when they said Samsung tablets, we said, okay, we're all in, because at least it works on a tablet like that. So he's on the road all day. He is, he's in his car. His battery is draining, right? And he's really big hands, as you can see, which is an important thing to remember when you're building a tablet interface for people. And he scores, and he inspects and scores all these installations and lifts and everything with his tablet and his native app that was already built for them. So what are August's problems? He has a very lengthy input form, right? It's literally hundreds of fields, because for one installation we have like the machine room, and the machine room has at least 15 things that he has to inspect. So it's very long. He also suffers from bad Wi-Fi, not just missing Wi-Fi or missing connectivity, but also untrustworthy Wi-Fi. You know, he doesn't know if he's offline or not. So what he usually does is he puts it on airplane mode, which saves battery, and at least he knows the state in which his device is in. It's also a very slow and unresponsive app that he uses. It's, you know, it has to go to the server, and the server says, here's the spinner, right? And then when he's finally done, he wants to save his inspection back to the server. The sync is unreliable, or at least he doesn't trust it, because, you know, maybe he has had bad experiences, or maybe you know, it's going so slow and he gets no user feedback. So all of these problems are things that you might think, oh, we can solve this with a progressive web app, right? That's what we thought. So we said, let's do it. One of the advantages, and this is about selling the progressive web app, one of the biggest advantages that we had was that August's boss, our product owner, he already knew about PWA. So I can give you a tip right now. If you want to sell more progressive web apps, just make noise about them that you make them, because we did. And clients actually come to us asking, hey, you build a progressive web app, can you build one for us too? Which is what happened in this case, right? Also, our product owner knows that web technology is maintainable, so that it's all JavaScript, or at least most of it is JavaScript, and a lot of people know JavaScript nowadays. The tools and the API that they use and that they already built are already on the web, so that was an easy one. And the most important part, I think, was that he is forming a digital landscape for his company, right? So he's already talking to us about other stuff that he wants for his clients as well, you know, like reports. So he has a digital landscape that he is establishing, and he thought, I need to have a PWA. This is my first starting point to you know, grow out this web landscape. So bottom line, all of this played in our favor. Our product owner was technically adept. He knew about the stuff that we were selling, so it was an easy sell, to be honest. And here's that big, dirty hand of our client. We call this in Dutch a coal shovel. If you've ever been in a steam train, coal shovel. And this is our nice, smooth office hand, of course, which is completely crushed. All right. So after that, we could start with our preparations. And the first thing that we did was a user journey session with an interaction designer, the product owner, and 3 workmen. I'd like to be inclusive, but there were 3 workmen, not women. And one of them was August, of course. He was there. And this user journey session, we had to establish all the wants and needs of our clients, and sometimes the things that they thought they want or need, they think they want and need, and that we have to turn them into a different want and need. Right, and at the end of the day, we had this list of IDs and a backlog, and some insight into their problems and the way they work. So this was very valuable for us to start off with. So the next thing for us to do is build a proof of concept, which as developers is something that we like to do, just to establish that a service worker technology solves our clients' largest problems. Because we may know that, you know, we have push notifications, we can go offline, or we have background sync, but our client needs to see it first, and especially some person like August, right? He says, yeah, my tablet works fine. I don't know if I need this, and then we can show him, hey, look how easy it is. So we had this actual user test with real inspectors like August in actual work situations. So we gave them a single page with a form with you're offline. Notice, and you're online again. You know, we could store things in the cache. We could do a background sync and a push notification, and this was all with a little Express server. And we just put it on Heroku, and August could run around in his elevator shaft, and with his Samsung tablet and Google Chrome. Yes, we're very sorry. Well, we just got lucky, right? I mean, we only had to build for Chrome and Samsung. But so this worked, and he was very happy. The next step was an interaction design, and this is, as I stated earlier, this is important, right? You cannot say we're building a PWA and have a lousy interaction or an unusable interface. So interaction design was an important part, and we built it with Google's material design. We could import these components into Sketch. They are lying around, and our interaction designer would then just build all the screens and put them online in Vision, have these click overlays on them. And again, August and the other people at our client's company could try to, does this work? Is my finger not too big for this button? And so this gave us two advantages. One of them was this immediate usability test. We could just give them, an interaction design click-through model, and they could just point out, well, this group of fields and this kind of information. We never put that together. It's not relevant for our work, and these kinds of inputs don't work for us. Or maybe I got sticky fingers in an elevator shaft, for instance. And also, because our interaction design was already kind of a visual design, because these material components by Google are fairly shiny, we didn't have to do the extra step of having a visual designer then paint over it. So our interaction design was immediately the finished product, as we could build it and more or less copy it into the browser. So August gave us the go-ahead, luckily for us. So to give you a sneak peek, this was our preparation phase, but of course you miss stuff, and the preparation phase was a long time ago, so now I know what we've missed. So I'm going to give you a little sneak peek so you can keep that in the back of your head during the presentation. Like, oh yeah, I remember you told this. What did we miss? We didn't investigate the existing API enough. We said, oh, it's JSON and it's RESTful, so it's probably okay. Check, the reference for what we had to build was partially the interaction design, partially whatever is in the API, and then some meeting notes. And then we thought, oh, we can probably, we'll wing it from there. But what we should have done instead is, spec, well, not everything maybe, but at least a lot more we should have spec'd and just discussed, and hey, what happens if this is missing or if that breaks. And also the interaction design was not 100% complete, and we were all on the same page. This screen is not completely done. It needs these extra ticks and switches, but we never really put that on paper. So everybody knew this screen is not complete. And then, last week when the project should have been done, we said, oh yeah, remember this screen that wasn't complete? It's still not complete. So we had to, these are the kinds of things that you miss, like a sort of minimum viable product definition, really. And also, for brevity reasons, I will assume that most of you know Agile Scrum or Agile Kanban. And we thought at first the project wasn't large enough. It was just too little hours, too little people, too few people. Is it few? I think so. Stannis. Where's Stannis? We thought the project was small enough, but in the end, in hindsight, of course, it became bigger. And then we thought, hey, if it's this big, we should have gone Agile and have an actual team working together on all of this. This is something, maybe you can never fix stuff like this. Anyway, next up was the team. Selecting the members of our team. I'm going to throw some stereotypes at you just for fun, and I have a political message at the end. No, okay, bear with me. So first up, we have, of course, the superstar frontend, right? So we have the ninja and the cowboy and the superhero in the middle. So these are important. And then, lucky for us, we got hipster designers. They know how to build flashy stuff instead of working stuff, because that's super important. Then we have our PHP ogre, our demon from the back end, and his motto is, when your only tool is a hammer, every problem starts to look like a nail. This is the kind of PHP developer we've always wanted. And then he says, it's a RESTful API. No, it's not. All right. And then we have the product owner. It's like, oh, I have a quest. I have a side quest. Here's all my money. He's just, his fingers are crossed, of course. and the project will be over in a second, and I'm super easygoing. But maybe he's not really a product owner, you know. He's being a stuck puppet. All right, but that's okay. Fun aside, right? This is the type of the typical stereotype things that, you know, I hate my backend or I hate my designer, and this is the stuff that you should avoid in any project, because all that this bad mouthing or you know, being negative about your coworkers doesn't help. We're all on the same side. We're all trying to build something for August. Nobody's sabotaging anyone. We're just a group of people trying to get this PWA live, right? All right. That was my start. I'm done. Okay, thanks. Architecture. Back to the topic. So we knew what we had to build. We knew the technology that we were going to use, how it would look, who was involved. This is the point where you can, I guess, kind of think about how you're going to build it. And it's also the most interesting part. So first up, we have the client, the browser. So this is a little home. This is a safe place, right? You have the little friendly robot, our service worker. The front-end server is next. It has a little space, you know, a little trunk to put stuff in. And it's really fast. And then we have the ivory tower where all the, you know, where the archives live and where you can put all your stuff in. And it's safe and it's solid. So that's the back end. So I'll take it from right to left to explain a few things about all these pillars that we have. So the back end, it was built very generic as a sort of a white label application. So all the code that lives in the back end is sort of can pretty much become any other app, which is an interesting way of building stuff. Not always easy for us to build something on, because you get a lot of overhead and a lot of metadata that you need to, you know, circumvent. As I already said, it wasn't really RESTful. It kind of was. It had these endpoints, but it wasn't really. And then it used the basic auth, basic authentication over SSL, which, if you're familiar with the subject, it's not the best way to do security. Because basic auth is, you know, you send your username and password over the line every time. Even though it's encrypted, it's still your username and password. So this was the backend. So for some reasons, we decided to put a front-end server in between. This is a concept that you may know or may not know. It's nothing spectacular. It's just there's a backend, and then we just put a machine in front that sort of consumes whatever and sends stuff to the backend, and that we can easily talk to from our client application. And why did we do it? Well, all the heavy lifting, like consolidating and reformatting all the data from the backend. If you do it all on the front end, it gets really heavy on the browser. So we just put it on the front end server. You know, it's for the heavy lifting. And also we have control over the API. So now we could build an actual RESTful API that was predictable and well documented, etc. So the front end server was built with Node.js and Express. Probably familiar for at least some of you. It was built for the browser, right? So we could do all kinds of stuff for this async, this asynchronous. I'm not even gonna try. Built for async. You know, stuff like pre-flight support. You know, your browser wants to do a check on the server. Can I just make a post or a put call? So stuff like that, pre-flight. Cross-origin headers and cookie session cookie stuff, and we had control over all that stuff. Then the service worker. Service worker used response caching for our offline functionality, so just to put images and CSS and JavaScript offline. And we use IndexedDB to save inspections that should go to the server locally first. And of course, while there is no internet connection, and from the other side, from the server to our client, we could store all this data, all this JSON in our IndexedDB as well. So this is for offline mostly, and then background sync obviously helps is the thing that you use when you want to send something later whenever there is connectivity. So this is the technology that we use in the service worker. And in the browser, our single page application framework, login, noted, React. Okay, well, at least, sorry? Oh yeah, that's new. Oh man, we didn't really get that. It was hard to understand. Patent issues with React. So I'll get into why we chose React in a second. We also use these material UI components. We already use them in the Sketch app, etc. And these components are also available as a package for React. So that was easy, or at least convenient for us to build our interface with. And then PostMessage is only a small part of the client app, but it allows us to communicate with the service worker. And for those of you who might be interested, we didn't use Redux with React because we thought it would be too much work. And then, damn it. Okay. So why React? Well, velocity. It's fairly easy to get things up and running with React, especially if you use Create React app. It just, you can get a website up and running in minutes, and then from there on you can build all stuff and get stuff, put stuff on top and everywhere. So it's very pluggable, extensible, and also maintainable. I mean, JavaScript is a very common language nowadays, and React is becoming more popular every day. So for us, this was like a go-to solution to build a single-page application. So this is about our architecture. Then also, I have to make a little note because it's going to come back later. There was this concept in our app that was the one object, and it was like and then people who know Redux and I think, aha, I see where it went wrong. We had this one object, an inspection object, and all the data about an inspection was sort of inside this object, and it was communicated to the client and to the service worker, and then in IndexedDB, and then to the front-end server, and it was always the same object. And this was sort of a solution that we had because we could always, modify this object, and it would render right, and it would be stored right, etc. So this concept, keep it in your mind. So now that I'm sort of halfway through my presentation, let's take a break. Well, not literally. I'm going to take a break now. Are we talking about a progressive web app still, right? Is this a progressive web app? It's a single-page application, okay? It has app-like animation and transitions thanks to the components library that we use. It has a manifest file, so I can install it on my device. It has a solid connectivity solution, with background sync and all this caching. So I guess that's a check. I don't know. Who knows? When I use 0% PWA, Lies already said if I put a service worker and a manifest file on my regular, I don't know, GeoCities. How do you pronounce it? Is it GeoCities? Okay. Website. Is it a progressive web app? Well, I don't know if GeoCities has HTTPS. But anyway, so when are you a PWA, and are you like, I'm 50? My website is 50% progressive. I don't know. So we just said, okay, this is progressive web app because it has most of the features. But this is always something you should, well, if you want the label at least, but you can discuss when is something a PWA. I'm going to go over to the technology now because that's, at least for me, that's very interesting, right? So this is your kind of typical situation. This is the client, that's the front-end server, could be the back-end server, doesn't really matter. I send a request and the front-end server sends one back or sends a response back, and that's basically how the internet works. Of course, something changed a couple of years ago with the rise of this little guy, the service worker. And now suddenly we're in the situation where my request actually gets caught by Mr. Robot, and Mr. Robot is friendly enough to send it through to the front-end server, right? So this is for very basic how a service worker works. Response gets back. This is important. The response also gets back via the service worker, and then the service worker can do something with it, and finally sends it back to the client, or not. Anyway, this is how it works. You send a request out, it passes along, it passes by the service worker, and also when the response gets back, it passes by the service worker. Now, say that we have this response cache over here, which is an empty box, and I can put stuff in it. The response cache can store an entire response object, right? And a response object is simply, something I can send or get from a server. It has data, it has headers, and everything. And I can just store it in my cache. I can use it to get stuff offline. And usually what you do is, and we did it in our case, is the index.html, index.css, JavaScript, images. We put them all in the response cache. And the service worker can read from it and write to it and then send something back to the server. So this is your basic offline functionality. And this happens when the service worker installs and everything is fine and dandy. And now we have a progressive web app. So things get a little more complex. We'll take the server out of the equation for a second. And so apart from fetch, which is when the client sends something to the service worker, it doesn't really know about the service worker. It just sends a request into the world, right? So it's not aimed at the service worker, but at the network. But there are also ways to let the client communicate with the service worker, and we use PostMessage and sync event for these reasons. PostMessage and sync event are both kind of you ask your service worker to do a task for you. So PostMessage is simply something that you send to your service worker, and the service worker says, "Oh, I know this assignment, I will do it," and then I might report back to you. And a sync event is what you do. You register an event at the service worker level, and the service worker knows that it has to do something whenever internet is available or whenever connectivity is available, which might be immediately, but it also might be, next week. And the service worker can then put stuff. At least our service worker in our situation can put stuff in IndexedDB, which is a database that lives in the browser and is accessible by the service worker as well as the client. And the IndexedDB can send stuff back to the service worker. So this is our basic way of letting the client communicate with the service worker. So when the front-end server gets connected, we want to do something with this construction, right? We want to download all our inspections. Because August is, he's coming up to a building, he knows connectivity is bad. So he says, give me all the inspections that I have to do for today or for this week and store them in my cache so I can check them out later. And so we send a post message. We don't do a fetch request because there is nothing to be fetched. We don't want an inspection. We just want to say to the service worker, hey, I might need this stuff. Go fetch it and I'll hear back from you when you're done. So we send an assignment to the service worker, and the service worker says, okay, I do, I don't know, maybe 20 requests. In our case, we pull at least 5 megabytes of JSON from the front-end server with all inspection data. And the server responds with an object, and the service worker says, thanks, I'll put it in my IndexedDB, right? And it uses the endpoints or the URLs of the actual endpoints that normally the client would use to fetch an inspection, uses that as a key in the IndexedDB, and it says like API.blah blah blah or API/blah blah blah, and this is the data that goes with it, and it's all stored in IndexedDB, and then it says to the client, and then I got your stuff, and then the client doesn't really have to do anything because we can show a message. Hey, you can go offline if you want because we have everything stored in our local cache. Check mark, done, and we tell August that he is good to go. Next case is about offline functionality. So what happens when the plug is pulled and we cannot reach the front-end server anymore? The service worker is now on its own. So we do a request. The client doesn't care. It just says, hey, I want this stuff. I want to render this page, or I want to render this inspection. And the service worker picks it up. It asks IndexedDB, do you have some data that matches this request? And IndexedDB says, sure, here's some JSON, or it's JavaScript object. Doesn't really matter. Service worker creates a new response. So this is an actual response, that the same kind of stuff that the client would get when when the client would go directly to the server. So for the client, this is exactly the same as going to the front-end server and just getting something back. And the fun part about this, of course, is everything we just built to make our website work offline and cache all these JSON responses from the server is built in the service worker. We didn't have to do anything on the front-end server, and we didn't have to do anything on the client. And by anything, I mean literally not a line of code. This is all service worker, which I like very much. All right. Again, for the next, let's save an inspection while we're offline. This is, the front-end service is now not available to the service worker or to anyone. We're offline. Okay. So we do a post request. The client says this inspection, August is done. He's filled out this list and he wants to post it to the server. He doesn't care whether he's offline or not. He just posts it to the network, to whatever, to the world. Well, one thing to keep in mind is that a post request can never be stored in cache. And this is part of the spec. I didn't invent it, but it is kind of logical, because what happens when you do a post, you create a new instance of some model. And when you create something and you cache it, it might be possible that when you pull it from cache, or when something goes wrong with the cache, you might create the same model twice, or the same instance twice. So that's why post cannot be cached as a response or as a response object. But you can, of course, pull out the data that was sent with the post request. So that's what we do. We just get out the data from this post request. Of course, we store it in IndexedDB. IndexedDB says it's done. You're okay. You're good to go. Apart from the request, we also send a sync event, or we register a sync event on the service worker. So we say, by the way, as soon as you can send it, the stuff that I just posted, as soon as you can send it, make sure that it gets sent to the server. Or, in our case. Yeah.
Do you still send a 200 as a HTTP status code for a post, or is that also not allowed? What we send back, you're asking, what does the service worker send back to the client, right? Yeah, because you say it's not allowed from the spec, but...
No, okay, so what's not allowed by the spec is to cache the post as a whole, but we can, of course, extract the data. So what we send back is actually the exact same thing that the server would send back, which is probably 204, which means no content. We just say, we're okay. You sent something, we got it, and the client just says, fine, I'm okay. So the stuff that we just posted, a sync event is registered along with it, and so that the service worker knows whenever I should do something with this post request. So now August is done, right? He can just, his work is done. His inspection is posted. The service worker knows what to do next. So the client can close, the browser can close, and August can go Netflix and chill, or for all I care, I don't know what he does in his weekends. So the server, we don't care about either. So this is what's left. And a sad little robot, he goes to sleep because there's nothing to do. So he sleeps and he sleeps, and at some point the server comes back, right, and he says, hey, I'm back. So the service worker wakes up and he remembers that there was a sync event that he needed to handle. He asks the IndexedDB, do you have this post data? IndexedDB says, sure I do. And then the service worker does the request to the front-end server. The front-end server then responds with the 204 or whatever, It says I'm okay. I don't care where this comes from. It should be fine. Looks good. And then the service worker can do a push notification to the browser over here, which then wakes up and says, yeah, okay, thanks. But who cares, because our client, or August in this case, already assumed that he was done with his work. He posted it. For him, it doesn't make a difference whether or not it was synced later. He did his job. He said post. The app said you're done. You can go on. So this is why we actually don't send a push notification in our app, because it might only be extra confusing to our users. So these are the things that we built as part of the service worker in our progressive web app. Next up, I want to take you through some of the things that happened while building, and the problems that we got during the building of this app. So I already told you about a little of the API hardships that we had. The remote API was very verbose and generic, and we had to do multiple calls for a single data point. So we were actually sort of joining different JSON objects together as if it were some sort of SQL, but very bad SQL. So this was a hard thing to do. This cost us more time than we had anticipated. UI components that we thought we could use, or of course, they were like 50% of what we need, and the rest was, custom-made stuff that, little knobs and ends that we had to make ourselves, which took more time than we had expected. So also we had the one object, and the service worker and the front-end API needed to be in sync with the one object. It was hard to keep track of the changes that we made, and of course during development I made a little change here, maybe my colleague made a little change there, and then somehow it looked like it worked but it didn't. So this was maybe a bad design choice. Maybe we should have used Redux to have this global state management, that we could always rerun our entire app with the right state. Anyway, this was kind of a problem, and maybe in a more simple architecture this wouldn't happen, right? Because we had all these silos, like the service worker, the front end server, and the back end server, and they all needed to work in tandem. Localhost, if you've already been working with service workers, localhost is easy. Everything works in localhost, right? You don't have to worry about policies, HTTPS. You can force the service worker to update. You can clear your cache whenever you want. And you take all this stuff. On the server it's going to be harder, but still, whenever you release or put something in production, you're going to be bit in the ass because it's harder than you thought. And you may have never thought about a cache busting strategy or something, which is easy on localhost. It's a button because you're developing. Yeah.
What about pre-flight issues?
Pre-flight issues are on localhost mostly not there, but it also depends on if you run your if you have a local API that you're building and you run it on localhost, then you won't have these pre-flight issues or course issues. But most of the times when you go to production, you either have a subdomain or maybe even another URL where your API is running, and then you get all these pre-flight and course issues. And if you have the luxury of running your server on the same domain, then you won't have to solve that problem. So one of the solutions to this problem is to have your API running somewhere else, or using ngrok or stuff like that to simulate server-like environment. But the problem is that the domain, the host name is the same.
Worst case, you can always start Chrome and disable app security.
Yeah,
I suppose.
Yes, for testing measures.
Yeah.
Yeah, definitely. But the bottom line is localhost is always easier and more forgiving, and you kind of miss out on stuff that you would in a production environment. Debugging the service worker can be a real pain. If you've been building a service worker, and at least in Chrome, I don't know how the debugging tools are in Firefox. there can be a real pain. You will be doing hard refreshes, you will be clearing your cache, rebuilding your entire app, and still it shows some old piece of code that you thought that was gone. And then finally, when you sort of bought a new laptop, oh, okay, now it finally works. So this is, I'm really curious. I wish maybe we should reach out to the polls and ask what's going on. Can you fix this? Also, error handling. This app has many states, right? We can be online, we can be offline, we can be offline with the service worker. We have items in our outbox that still need to be synced. We can have partially downloaded inspections that live in our local cache. So all of these states and all of the error codes that a server can give out, we have to manage in some way. And but should we inform the user of every kink? Are you going to show up a little snack bar? That's what it's called in Google Material Design. These little things that go like this. It's a snack bar. Nobody knows why. And should you say, oh, the thing that you just tried to do sort of partially failed, but I'm going to try to do it again anyway? And will the user be very happy with these kinds of messages? So usually you have your client and your server, and then when it's a 404 or 500, you just say, hey man, it didn't work. But now suddenly you have all these extra options that you can do and handle. One of the positive points, let's keep it positive, the proof of concept was a great reference for us to build a service worker with, because we had already built sort of our end product. So we already knew what we were going to do and how we were going to do it technically. And this sort of, to me, proves that adding a service worker to your project, even if it's not a full-on progressive web app, is I think you should always do it, regardless of what the client says, because it's doable and it's highly rewarding. You know, for us to add small offline features, etc., was fairly simple, and I guess the least work of this project was building the service worker. So here's our cowboy again. Why? Because we did a lot of cowboy coding. Then we needed the ninja, right, to come and clean up and do all the little hacks to make it work. And of course, our superhero to keep the client happy. So we were still a team of awesome. So what did we learn? Start with solid error handling and make some sort of spec. You know, write out what kind of errors can we expect. What don't we know? This is something that we would do next time. Test more, always, okay. Test more. This is a default slide in any retrospective. This is an important one, because suddenly we're sort of full stack developers, and we're managing persistence locally and remotely, and we're also building microservices. So we went from, you know, writing CSS and maybe a little JavaScript to actually having databases that we need to manage locally, and we need to manage storage and also clean up, because your IndexedDB can get fuller and fuller, and at some point your cache is going to give out. And I don't know what the error messages that Chrome gives when your cache is full, but I have never handled it. So now you have a little tiny server living in your browser, and it's really peculiar and uncommon, and nobody knows anything about it. So this is a big one. You're not just building a regular website anymore. Little thing about the improvements. This is actually a backlog. Maybe we can write it down. I'd like to have a scoped service worker, which means that, you know, we put everything on one service worker, but you can have many, or at least more than one. So in the scoped service worker, we could handle the assets like images and CSS and JavaScript, and then in the other service worker, we could do the API caching, or the API mirror, as it were, which would be a little bit of separation of concerns. And this is, for me, the one thing that a project like this would boil down to if I had the time. Because if you're talking about a progressive web app and what it means to have an actual app instead of a simple website or even a complex website, what makes it different is when it actually starts feeling like a sort of an end state application, which means maybe I want some notification center showing Am I connected or not? Can we have a log of the inspections that I did or didn't do, and that were synced or that I had problems while syncing? Can I have preferences like send me push notifications only when my sync failed, or send me or download all inspections at the start of the day, or only once a week, or let me do that by hand? So, and this, you know, the way you would handle or render this could be very happy and could be very personal. And to me, this is what makes your PWA have an actual sort of an end state, right? It becomes an actual app with personal preferences. Am I done? Yes, I am always done. Is the app done? Yes, the app is almost done. It's almost live. It's now being, well, next week I hope it's going to be tested by the actual people in actual situations, and then a month after we are going to production. So it's not a PWA in production. Ooh, I just disqualified myself for this talk. Should we do progressive web apps in production? Yes, absolutely. If you already have HTTPS enabled, do it. I mean, don't even tell your client. I think that Jasper was already saying this. We just do it out of the box almost now, because it's, you know, the core concepts are easy to implement, and since it's a progressive enhancement, it will just work where it works, and otherwise you'll just have your old working code, right? So the bottom line is do it, and that's me. Thanks.
Are there any questions?
Yeah, I'm wondering, why are you using a separate front-end server? I mean, couldn't you do the same stuff in a controller and backend server?
We could have, I suppose. Well, first of all, the backend server was being developed by someone, you know, a freelancer working for our client, and yeah, we could have pulled him into our team and then let him build the stuff that we need. I think it would have been a lot of extra work, and because he was building this generic solution, he didn't feel for it much, and I guess we just said, well, we do it a lot actually, and the front-end server can be very thin, like consume stuff and then send it forward. Sometimes even just send it forward directly, but at least we have some control over headers. But yeah, absolutely. If I guess my first goal would be to always try to convince a backend developer or backend team to make stuff great for us. But as you probably know yourself, it's hard to get those guys in line. Yeah.
How do you handle with API changes? Because you can have like a living app on the client for weeks without internet connection, and once you get online, you have like completely messed database.
Yeah.
Backlog.
Huh? Yeah, backlog. Yeah, that's a very good. Yeah. In theory, you could have something. Well, we have versioning. The API is like /API/v1. That says, so if we would go into production and update our API significantly, we would just go v2, and then because this response or this object that needs to be sent to the server is still looking at the old API endpoint, I suppose we would be fine because it's still looking at v1. But at least we had to make sure that the v1 is still available. But it's a very, very good point. I'm getting nervous now.
But also the same thing goes when you have data in your IndexedDB and your front-end code changes.
When
you have old data in your IndexedDB,
yeah,
front-end code changes too.
Yeah, absolutely. So you have to think a little bit about the choices you make. Keep it simple is usually the best solution.
And one good thing would be to make got a deal with the client. For example, say like, we're sure that every device is online at least once every 2 days, so then you don't get blamed.
Yeah. Okay. So in a controlled environment, that's a good. That's important. No, but in a controlled environment such as this, where you can actually tell your client and their people to do certain things because this is literally 8 people work with this. So we can probably reach out to 8 people and say, hey, you have to sort of reset your device. But in a real situation,
the API.
yeah,
Go into
yeah.
Wi-Fi. Yeah.
then they get an email. No, but in a real world situation where you have I don't know, potentially hundreds of thousands of visitors, you don't have these luxuries, right? Yeah.
What are the chances of the sync to fail between the service worker and the server? Let's say if you're offline and the sync did not happen, do you lose your data? Is there any chance of losing your data?
Yeah, definitely, and there's a very big chance because the sync, connectivity can pick up for a fraction of a second, and if that's the moment that the sync is trying to send data, because the sync is going in sort of increments, just keeps trying, and then at some point it will have an internet connection, and what if the internet connection drops halfway? You'd have the old situation of sending something into the void and not really knowing what happens. So you have to cater for that, and a simple solution, or at least that's what the sync API provides, is that you should only, if you're familiar with promises, you should only resolve your promise if it actually happens. So you should always, when a sync doesn't happen or the server doesn't come back with something satisfactory, you should reject your sync event, which will then keep trying. But this is stuff that you have to test with, and I don't really know.
You don't clear the data out of IndexedDB until you have a successful sync.
Yeah, 100%.
Right? Yeah, exactly.
Yeah.
Have you also considered PouchDB as a database instead of playing IndexedDB?
I think we considered it, not for very long. No, I mean IndexedDB was a very easy one to pick up, and also because I'm not sure if PouchDB also lives. Isn't PouchDB an abstraction on IndexedDB? Yeah. Yeah. Well, we don't really need. We could have used IndexedDB as just a key value store, and Pouch is much more of a non-relational database, and we just needed something to put stuff in.
Pouch also only syncs with Couch, right?
Yeah, I think so.
Okay, that's the reason why we didn't use it. Yeah.
A bit off-topic question about the life cycle of the service worker, because you probably may have research that since you've worked with Samsung and Chrome only, this kind of stuff. So when you close your browser, your service worker still is potentially asleep, so it can still be awoken. But what about you for stop of your app? Does the service worker have the Chrome or whatever, does it have a separate process? Or what after you restore your Android device? Is your service worker ready for some connectivity then?
You mean whenever you close your browser, or if it's an app, as in a PWA? Yeah, the thread lives. It's alive.
Okay, so it's always on, always.
And this is, of course, this is something that you have to. Well, this was easy because it's only one device and one type of browser, but the way Chrome implements their browser on different devices is probably interesting. If they follow some sort of spec, and nobody knows yet probably how, but you should be, as a developer, sort of rely on the fact that browsers are built, that they can have daemons running in the operating system that make sure that they are alive. But okay, at some point you're just gonna hand it over to.
There's actually not just the one service worker, so you could have 10 of those little robots, because the browser knows that one is registered. So if the page knows it, if it tries to send something to the network, it will check, is there a service worker? Then it will spin one up as a background process, and it could, if it does a lot of things at the same time, browser might decide to spin up 10 service workers do the same thing, so you can only do things in the event loop. And also, if the system receives basically a push event, then it will check, is there one running, and otherwise it will spin one again. So if your service worker crashes, it will just spin up a new one.
Okay. I was asking because I was playing around with the push notifications, and after I restarted my device, I didn't get a push notification. I wasn't able to, but
maybe it's just up to my device. Then maybe something when.
Well, this is the probably the sort of the gray or the twilight zone that we're in now. You know, with all this development. But okay. Interesting. Write a blog post.
That's what I got in the gray zone.
Oh yeah.
Cool.
I would like to thank you, Anna. Maybe there's more questions, but there's also still beer left, so I think we could combine those to have a short break before the last stop. So also you, Anna, thank you very much for your time.
Thanks.